Subtract mixed numbers. A couple of warm-up exercises. Fill in the blanks. How many fifths equal one whole? 5. How many eighths equal one whole? So what is it that you know makes a whole with a fraction? How can you explain it, Brandon? Numerator, same as the denominator, you have one whole. Now, this equal sign basically tells you that it's the same thing. It's the same exact value. Just like if you were using money, and maybe you had a $1 bill, and maybe you said 4 quarters. It's the same amount, just written a little bit differently, or just expressed in a different way. How else could you show $1? You could have 100 pennies. You could have 10 dimes. You could have 20 nickels. You could have a combination of quarters, dimes, nickels, pennies. Okay? Just different ways in which it's expressed. Today, when we subtract mixed numbers, we may come across situations like that. Now, I'm going to start you off pretty easy. I'm going to start you off pretty slow, pretty basic, but then we're going to have to remember this concept here. Okay? 3 3/4, and the 3 3/4 we'll take a 2 5/8. So generally speaking, the same rules apply. In order to add or subtract, in this case subtract with fractions, they need common denominators. So again, we'll look at my larger denominator, which happens to be the 8. And yes, 8 does work also for 4. So 4 times 2, 3 times 2 is 6. This will stay the same. 6/8 minus 5/8 is how many eighths? And then 3 minus 2 is 1. If the 1/8 is in simplest form, okay, then everything is fine. Okay? Question on this concept, Joe? Well, we'll get there. So like I said, I'm starting you off pretty basic. All right? Try this one. Try 7 3/4 and take away 6 2/5. Trinity. We'll use the 20. Very good. 5 times 4, 2 times 4 is 8. 4 times 5, 5 times 3 is 15. 15 minus 8. And 7 minus 6, 1. 7/20 in simplest form. Good. How many of you got it? Outstanding. Okay, let's walk through this one together. Between the 5 and the 10, I'm going to use the 10. So that will stay a 1. 5 times 2, 2 times 2 is 4. Now, is there a problem here? If so, what is it? Just my asking if there's a problem will tell you that there is a problem. What is it? Sarah? Yeah, you got it backwards. Yeah, I can't take 4/10 if I only have 1/10. So in other words, to solve my problem, I need more tenths. And I need more tenths up here. Okay? Now, if you flash back to the other exercise that we did, here I have all of these different fraction examples that all equal 1 whole. So as we watch, I'll say, all right, I'm going to take 1 whole from my whole number column, and I'm going to transfer that over in fraction form. So what is 1 whole in fraction form when I'm using 10 as a denominator? Right? So if I have 1 and I'm using tenths, it means the same thing as 10 tenths. So I'm just going to transfer it over. So I'm going to bring 10 tenths over to the party. There's already 1 there. So the 10 tenths I'm bringing plus the 1 that's already there is now 11. 11 minus 4. Now a 9 minus 3 is a 6. Okay? It's called renaming. And we kind of did that a little bit for today with the mixed numbers when we added, but now we need more in the fraction column. Yep, you're going to do one right now. 3/8 minus 1 3/4. Good. It's a 3/4. If it was a 1/4, you would have it right. Right answer, wrong question. Good. No. There. There it is. Good. Close. How many eighths equal 1 whole? Because you're using eighths. How many? 8. So you're bringing 8 over to the 3 that you already have. 8 plus 3. Close. So if you took 1 away, 2 minus 1 doesn't give you 2. Make sure you make that whole number larger. Good. 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 Subtracting. All right. So you have 3/8 and you have 6/8, right? You need more eighths. You took 1 whole away. How many eighths is 1 whole? Right. So you just add eighths to the 3 that are already there, and you get what? 8 plus 3. So not 31, but 11. It's 8 times 2 is 6. Problem is I can't take away 6/8 if I only have 3. So again, we'll need to borrow. How many eighths did I just borrow from my whole number column? Not 1/8. 8/8 plus the 3 that are already there. It's now 11. What? I don't always change it to 11. It just happens that the first 2 examples we did, it changed to 11. Okay? 8/8. I'm using eighths, right? 8/8 equal 1. So I'm going to bring 8/8 over to my 3/8. It's 11/8. Okay? 8 plus 3 is 11. Just like before, I had a 1 and I added 10. That's why I had 11. So it's not always 11. 11 minus 6 is 5. 2 minus 1, 1 and 5/8. (23 minus 12 and 6/7). Problem here is I have a 6/7. I have to subtract the fraction column first. How many sevenths am I working with? How many sevenths do I currently have? I don't have any sevenths there. Can I take 6 away if I only have 0? So I need more. So if I borrow 7/7, right, which is 1 whole, add it to the 0 sevenths that are already there. 0 plus 7. Is 23 the same as 22 and 7/7? 7/7 equals 1. 22 plus the 1 is 23. 7 minus 6, 1. 22 minus 12 is 10. Josiah, you want to walk me through?
You got 32, but 0 over, you should put 0. Take the 32.
Take 1 away.
But 2 over top of that, you subtract 2 minus 1. You don't have 31 minus 6, which is 15 over
15 and a half. Very good. Well done. 15 and a half. You get it? Good. Okay. Is there a difference between a problem that looks like this and one that looks like this? There's a difference. Because how many thirds are here with the 15? If you don't see any, it's the same as saying 0, right? Can I say 2 minus 0 without any issues? Without any problems? Yeah, so in that case, I can bring it right down, and I don't have to borrow anything. All right? So if it helps you, when you don't see a fraction there, if it helps you to just put a fraction of 0 over whatever the denominator is, then by all means, go ahead and do it. If you need to visualize that to see if that makes sense, go for it. Okay? Now, any questions before you get your assignment, or are you good? You want to do a couple more?
I'm good.
4-5 on the back. Pick a column from 1 through 24.